Righto, so I guess we'll get this this Zoom webinar started. So first of all, I just want to say thanks to everyone for joining today. Like, we know it's a busy time of year, whether it's harvest or other jobs on the farm, it always seems to be a little bit hectic. So thanks a lot for joining. What are we doing? So this is basically part of a soil extension project, which has been funded by the GRDC. So it's got involvement by the New South Wales DPI, and then a bunch of farming systems groups. So we did one yesterday, which was FarmLink in Central West, and now we're going to go down to sort of the IREC and ICC and Southern Growers region. And on the line, we've got Sam North from New South Wales DPI, and then Pat Hulme, who's done some work with IREC. So they were both out there. They've done some soil pits, and we'll go through some of that. The key things we're looking at is basically when you're in a pit or when you're out in the paddock, what things can you look for to identify soil constraints or soil characteristics? So what do we actually, we're in the pit, what are we looking for? And then once we identify those constraints, we'll have a bit more discussion on how we manage them and where current research is up to on best practices, basically. So Sam, I'll pass it over to you. And yeah, if you want to just go through.
Share my screen.
Share your screen and start your presentation.
Righto. James has given us a great intro. Acknowledge Pat sitting there because he was a big part of this. Eva, Mel, Steph and Alex, and particularly Mel with editing these videos. They've done a great job. So full credit to the cropping groups. Just work out my tech. And as James said, there are a couple of things. If you take nothing else from this presentation, I would like you to take these 5 key points. We're looking for colour, texture, structure, organic matter, and there are 3 simple tests that you can do: pH, acidity, slaking, dispersion, and EC. I talk about those in the 7 minutes of video to follow here, so I will start on that. But as I say, I'll say it again: colour, texture, structure, organic matter, and those 3 simple tests. These soils have iron in them, and when they are predominantly wet, and that iron is in a reduced state and it gives you your grey colours. And when you get lots of oxygen in those soils and they're well drained, the iron rusts, it oxidises. So if you want to remember it, you know, rust is red. Red soils are oxidised, you've got oxygen in those soils. So the red soils are generally better well drained than your grey soils. So just looking at this soil now, predominantly grains in the top, and you go, well, you know, like that's a bit of a hint, apart from the fact that we're standing in a rice bay, a bit of a hint that this soil is probably not as well drained as red country. The other determinant of colour is obviously in a surface, in an A horizon will be organic matter, and that will give you blacks generally. Like you'll see it most noticeably on a sand hill or on sands. You know, you've got that organic layer on top and it'll be a darker colour, and then you'll go to more leach colours underneath. There are, and you'll see it in the bottom of this pit, it's actually mottled, and that's an indication of alternating wet and dry conditions. So you'll have conditions in the subsoil here where you'll get oxidation, but within cracks where they might have more water, it'll be greyed and glayed. Grey is not as bad as that. You've seen it in rice country, you know, like after draining, for instance, or in midwinter in some of this country, it goes that bluey grey, and that's really reduced. So it's waterlogged conditions. So you're going from red through grey to bluey grey, and it's sort of really well drained to not drained at all. Texture is your clay percent. You assess your clay percent by taking a half a handful of soil, slowly wetting it up and working it. And if you can roll it into a 6mm ribbon without it cracking and get that to form a circle, that'll tell you it's a nice heavy clay. This one will be something like that. The other 2 fractions are sand. There's got sand, silt and clay. So sand, obviously, it's gritty. So sand is the large particles. Next size particle down is silt. Silt is like a small bit of mica, so it's flat, but it's got a large surface area, and it feels silky. It's not so sticky, but it feels smooth like silk. All right. And you think, well, clay feels like that, but no, clay's the next size down, it's smaller again, it's sticky. You wet it, it gets sticky. And clay also has bounce. So you wet it to a, not saturated, but a half wet, and like it'll have that sponginess to it. Why is that important? Again, it has to do with one, ability to hold nutrients. So it all has to do with surface area and the charge that's on that surface area. You've got coarse sand, you've got big aggregates, so they don't have much surface area for the volume that they contain, and they don't have much charge. But they're loosely packed, and there's lots of air between them, so they're well drained, but they won't have a high cation exchange capacity, and they won't hold nutrients. So the implications for irrigation particularly is that you need to put small amounts of water on frequently, and you need to put small amounts of nutrition on frequently. So you put a big dump on and they'll leach. You move to silts, so we're talking about our loam sort of soils. They're generally in the middle. They have good structure, they drain well, they've got a reasonable amount of surface area and charge, so they can hold reasonable nutrition. And so they're often our better soils in that mid-range. You come to light clays, heavy clays, to quite heavy clays here, 30 to 50% clay. And we've got high surface area, high charge, so they've got really high cation exchange capacity. They hold on to a lot of water, but because of that ability to be compressed, they can squash down and you can lose the air in them. So because they're fine particles, if they do squash down, you lose the ability for that soil to transmit water, and that's pretty key, and for roots to grow through it, which is we'll talk about later on. Clay is a primary determinant of structure, which is the next thing to look at, and structure is how your soil is held together. So if you think of a sand, there's no structure in it, it's amorphous, it's all the one. And as you come into that increasingly smaller particle sizes, you'll get an ability for those small colloids and clay particles to stick together because of that surface area and charge, and they form aggregates. And you will have, for instance, like in the topsoil here, there's an aggregate there. It's got lots of roots through it, and you'd see it breaks slowly, or not slowly, it'll break with very minimal pressure into smaller and smaller aggregates. And that's really what you're wanting. You want aggregation in clays because that's how your water and your air get in there. But as you come down, we've come into a higher clay content in the subsoil. It's a bit larger. Again, you've got roots through it. It does break down with minimal pressure along those breaking planes, so that's quite good structure. You end up with something around about that size. So that's good structure there. You come down even further underneath, and it's actually quite hard to drive that pick into it. And this, not many roots, and it's actually quite hard to break apart. It's drying, so when it was wet, it was actually just a solid block. So your structure is quite critical. You can pick it from the way that the soil aggregates. What you want is structure, what you don't want is no structure. The organic matter, that'll be roots, is what you're looking for, and darker colours. It's pretty obvious here you've got this root mat in a cultivation layer. It's actually lighter than the soil underneath it, and that's just because we've got actually a lighter texture within the cultivation layer. So because this is a dark coloured soil anyway, we're really not getting that differentiation in the surface soil that you might get in the reds, or particularly in the sands where organic matter makes a real difference to colour.
Text. Soils exist within a landscape, and there are associations, certainly on the riverine plains, between the soils that you have and the vegetation that sits on them, and also the topography. And it all has really to do with drainage out here. On the left of your screen, you can see you've got sandhill soils, so they're higher in the landscape, they're coarser textured, they're better drained, and you get white cypress pine and yellow box on those soils. And as you come down off the sandhill, you get those red-brown earths. They've got 15 to 25 centimetres of a red loam over a clay. They are quite productive soils. Again, you get grey box and bull oak.
Then you come down onto country that's less well internally drained and it's flatter. So, you know, 1 in 2,000, 1 in 1,500, even flatter grades. And you'll get predominantly boree on that. Again, further out on the back plane, which is what you just saw there at Tullacool. You get those grey and they're generally sodic, non-self-mulching clays, boree, saltbush, Dillenbush. And then the final one is, look, it's closer to, you know, watercourses, and it's actually on the existing floodplain. Oftentimes, they're pretty new soils, all within there. You know, like you can see that grey bar underneath it. Self-mulching clay and gilgai can occur anywhere here. That's a generalisation. Generally, those self-mulching clays, they are calcium-dominated clays or calcium parent material. As opposed to the non-self-mulching clays, which will be the sodic type parent material. And so they, what's called 2-1 clays. They basically are highly shrink and swell. And so they're really, those self-mulching clays, they're good summer cropping soils. They've got good structure. The main point I'd like you to take home from that slide, I guess, is that, you know, you're standing out in the paddock. There's veg around, you can get a real idea of what soil type you're going to be on just from the vegetation. So, you know, using your eyes, having a look around, gives you some clues as to what you're going to see.
Oh, that's good, Sam. Sam, can I
go
say,
for James? Yep.
As we go along, anyone who's got any questions, just put them in the little Q&A box down the bottom there. I think it might be on your screen. Question and answer box. If you put them in there, we'll either read them out as we go along, or we might just wait till the end of each segment. We'll go through those.
Yeah, I'm happy with either, James. I can't see that at the moment because I'm sharing. So
no, I think I've got that. So even if it's just a question about your constraint, you might have something similar or whatever, just put it in there. We'll get to that at some point. So
So this is where we're moving now. So you see that there's 5 soil profiles in the top of your screen. And from left to right, you've got a sandhill soil. See whether I can use a marker. So your sandhill soil, your red-brown earth, transitional red-brown earth, non-self-mulching clay, and self-mulching clay. And you're looking at this, you can see structure in it, you can see colour in it, you can see the roots growing down. There's roots down all the way down here. That's 80 centimetres. And, you know, you get some idea that this is actually not a bad soil. Like it's actually that aggregation that we were talking about. The key indicator for me when there's a crop on it is how deep the roots are going. That's that profile there. You can pick it often in natural. You've got the bleach state too. Transitional, we don't have as deep a topsoil, and we come down generally into sodic subsoil. And this is the case in the Finley pit. It's a bit hard to see in this one because it's an oblique shot. But we've got, you know, a smaller topsoil here. We've got a B1 and a B2, I would say, and then we go into a C. And you see this other characteristic of plain soils is when you get deeper, it's white mottling, which is carbonate, calcium carbonate. So it's precipitated out. It gives you an indication in a soil of what the previous long-term depth of the wetting front was. Yeah, with irrigation, we've leached salts out and we have extended that in many cases, but you can see there's not a degree of aggregation in this centre one as we had in the red-brown earth. So you get some sort of hint when you're just looking at this, like say the Finley site, it's probably not going to be as well drained as the red-brown earth. Next one along is the Tullacool site, so you've had a bit of a look at it already. So this is the non-self-mulching clay. The standout feature at this, when you open this pit, was this root mat, 10 centimetre deep root mat on top. Again, I've got a bit of video on that. You can see roots are going deeper, but the amount of roots in here, in proportion to the amount of roots in here, like it's just standout chalk and cheese. So looking at that, you're going to go, well, there's something happening here, and that's probably going to be a limitation. What you would rather see is a uniform distribution of your roots gradually getting smaller as you get down. Right, so we've got another little bit of video. What struck me about what you were saying is, you know, you've got this bit of soil that you've damaged, but you've still got good structure and everything like that in your plant zone. But what you do in order to fix this is you destroy this.
Yeah.
And so, you know, it's really about finding a technique to renovate this traffic lane.
Here.
Yeah.
Don't bother about that.
No.
The soil that you have spent the money loosening is the soil that is most susceptible to compaction.
Right.
And you want this here bit compacted because this is your roadway.
Yeah, right.
And anyway, and in time the farming system, I believe, will come where you can have your road anyway.
Yeah, so you
Have your roadways.
we'll get to a point one day where we'll have our roadways we won't touch.
Yeah.
With a ripper
You won't
time,
rip them ever.
Correct.
Yeah.
and you'll farm in between,
Yes.
so to speak.
In that deep ripping is useful if it gets the roots access to a better place.
Yeah.
Yeah.
So the issue is if you pack the living daylights out of that and then rip it, you get the roots to the compacted bit.
No, yeah, they grow through the soft bit into the
They go through the soft bit, they get to the compacted bit and they say, oh, bugger it. Deep tillage is really effective as if you have a compacted layer here and good soil underneath, and you can rip through the compacted layer into what's underneath, and then you look after the holes that you've made in the soil, then deep tillage is a really useful thing to do. If you make a wall of compacted soil between the furrow and the hill, then you want to do something about that.
Yeah. So where the compaction is matters.
Yes.
Yeah.
So here, it's a roadway.
And the more you can compact that, the less impact you're going to have on the shoulders, isn't it? Because it's going to hold the machine up.
Yes.
Yeah.
And the less it costs you to drive over it.
Because it's not soft.
Well, because otherwise your tractor's driving uphill all the time
Yeah.
to squash down the soil,
Yeah, keep going.
sort of thing.
They're 1%ers, aren't they?
So Dallas, there's, you know, like,
Yeah. And the hard setting red soil
Yeah.
is really difficult to fix long term.
Yeah.
Because
Okay.
it's a function of the particle size distribution.
Right.
That it's a mixture of fine sand and silt and clay, whereby the fine sand makes a framework,
Right.
the silt and clay block the holes up,
Right. Okay.
and all go sticks together.
So-
There's a compacted layer here that doesn't matter because it's got gaps in it. Compacted meaning strong, but there are still spaces around the compacted clods for the roots to grow. So structure management is about holes. So it doesn't matter how bloody hard this is, provided there are holes through it.
Because plants will find that hole.
Well, plants and water will find the holes.
righto, next.
So I guess Pat, do you want to add anything to that? So you basically compaction is your big issue there. You're trying to trample your furrows and protect your beds and your hills. Is that the take home message? Do you want to add anything?
Not really. Yeah, so you want to separate your roadways from where you grow the plant. In the furrow irrigated system, you want to separate the roadways which support the machinery from the places where you grow the plant, where you want the roots and water and everything, and air to move rapidly through the soil. So that'll do.
Yeah, it's a particular problem in cotton systems because round bale pickers are so heavy. But I would be encouraging every single cropper in this forum to be thinking about tramlining their machinery. It's a long-term project, but you need to be thinking about it, particularly on clay soils. Pat, you made a really good comment around hard setting in red soils and how difficult that is to manage. The key to actually getting structure in those hard setting red soils is having organic matter. And that's really difficult in the intensive irrigated cropping system, but it needs to be done. We can talk about that a bit later. And the final point I'd make, and Pat made some really good comments about when deep ripping is effective. if you've got a restrict, where deep ripping won't be effective is in sodic soils, because they'll just, it won't last. You spend a lot of money to do it, and they just disperse and they melt back down and they lose that effect. We'll talk a little bit about that after this next bit of video. We're back to the Tullicool site, and I'm sort of talking here about that difference between that topsoil layer and what's underneath. This hasn't got the oats on it. It's just got, well, whatever that was, ryegrass mainly. But you can see I've been able to pull that cultivated mat off, and you can see, you probably can't because I've got that in the road, but the bottom surface, and come forward if you want to have a look, you've got the bottom surface of that zone where you've got the root mat, and you've got the top surface of the B horizon. And the bottom surface of the A has got a lot of roots coming out of it. And the top surface of the B has got bugger all roots going into it. And this is a restricted layer. That actually may be, you know, like there's been a disc through there and there's been a disc through there, maybe. You can make this sort of stuff up. But you can see, I mean, and part of that polish may be the fact that, you know, I'm brushing it, but I suspect not. There is a little bit of a polish on that as well. For the constraint is not so much this, it's what you do here. And what you want to do is manage these two together. And I'll just to explain that, what you've got is you've got good water entry here, but you cultivate it, and before that crop and the root mat goes through it early in the season, you know, you're coming out of autumn, you cultivate it in autumn, you seed into it, and then you come into winter. And we can get wet winters, and so that can fill up. And because you've cut off the pores here, that tends to slump, and you've made this smooth surface, cut it a bit, and that doesn't drain. So you get this ponding of water on top of that because you've disrupted the connectivity between those pores. Can you operate in this system without that? I'm not sure, because part of the reason why you guys are cultivating is weed control and moisture retention on fallow. So, you know, like it's how you actually manage this within the rotational system. The solution, you know, like, is to get things growing through it and to give yourself a reasonable period too. Drying helps. You know, look, I look at this and I would say, you know, like an obvious thing may be to, you know, come through, you know, all the machinery, all the tines you're putting in here, probably operating at around this depth, because anything underneath that, it's going to take a fair bit of horsepower. But if you can get narrow points into that, like 2.5 to 5 centimetres, and just tickle that up underneath that without disturbing that, when that is, and that's the critical thing, is the moisture content at which you do it. And it's not the moisture content that you do it at the moment, because that's just going to smear. So the rule of thumb is that you err on the dry side when you're cultivating clays, and on the wet side when you're cultivating loams. Like if you do loams when they're too dry, they'll powder, and if you do clays too wet, they'll smear and deform. So you'll get, it'll take more horsepower, but you'll actually get a little bit of shattering. And when you get that little bit of shattering, you'll get roots growing into it. And so 1 year of roots into it, the following year, like annuals, those roots will die, but they'll leave that path open, and it'll also form a bit of a weakness for cracking as well. So the following crop, the roots will grow into that, and it builds on itself.
A little bit in that, this is, as you can see, the Finley soil and the Tullicool soil. So the traditional soil and the non-self mulching, and this gets to that acidity issue. We're talking now about those 3 simple tests that you can do. You know, acidity, where you can get a field test for doing acidity quite simply. You can do electrical conductivities. It's a little bit more tricky. You need an EC meter. But one of the simplest and most effective tests for assessing your suitability for soil and what your constraints might be out here is to do this. You get some rainwater and you drop some centimetre sized cubes, like intact aggregates, into that dish of soil and see what happens. Leave it for 5-10 minutes.
And you'll see, I don't know whether you can see my point. I'll try and get the laser again. So this is the topsoil at Finley. It's relatively stable. It hasn't really melted down. What I would expect, and the issue that Pat was talking about around hard setting red soils, you're really looking for this. So you don't have the cloudiness, which is dispersion, but you do get the aggregates. They just sort of melt down. That's called slaking. And where you get this cloudiness, that's called dispersion. Where you have slaking, it'll be an indication that you have low organic matter, particularly in those loam soils that Pat was talking about. Where you see this dispersion, that'll be an indication of acidity. Yeah, so you can see at Finley that there's dispersion happening in the B horizon, more so here. At Tulakul, we've got dispersion also in the B horizon, but we're also getting a slight bit of dispersion and acidity at the surface at Tulakul, but it's held together a fair bit by the amount of roots and the organic matter in it. And so organic matter is a great thing, again, for helping you combat acidity and also for slaking. So easy test, and it's one of the best indicators, I reckon, for soils out here. And I guess we can now, I'll put this up. I don't know whether I can't really share this and change my screen, James, but one up there that we haven't talked about and we have touched on is acidity. But I think most people are aware of acidity, and if you've got acid soils, well, you need to test them and then lime. It's pretty straightforward. That's comments around machinery compaction, particularly in cotton systems, but yeah, roadways. Slaking and hard setting, again, touched on that. It's a real issue as far as water entry, particularly under sprinkler systems, but it really does affect crop establishment. And then, like that's bottom line stuff. It's an issue in those soils that are dominated high fine sand and silt content that Pat was talking about. And the solution, which is not an easy one, is to increase organic matter. So, retaining stubbles, minimise till. And the work that was done is 40 years ago now up at Trangie was avoid bare fallows like the plague. Now that's not easy, but if you can work towards that sort of thing, you're on to start. Subsoil acidity, you may not, it's the Sunday soil syndrome, like they'll be waterlogged after a bit of rain, and so surface drainage is key in those. They tend to dry, they'll be moist, and then you come into spring and then all of a sudden you'll find they'll be dry. So putting something into ground to measure water content to help you with your scheduling, so that if you've got a crop, you want to get a high yield off it, then you're actually watering on time and not after it's too dry. They do occur naturally. They've been rice systems because they're not leaky. So that's, anyway. Right, James?
That sounds good, Sam. We'll just so I guess two of the bigger ones you mentioned there are slaking and acidity. So I guess with that Tulakul site, and you're talking about ripping, if you do a dispersion test and that's sodic, I guess that means you're not going to have any long-term effect with your tillage.
What I was trying to get, and I don't know whether I explained it in that little video, is that ripping won't solve the problem at Tulakul, and it certainly won't solve it at the Finley site either. And paraphrasing Pat, because what those guys were doing at Whitten, up on those cotton systems, you'll get the picker in, it'll be a wet pick, and you'll need to go through and renovate that. And you tend to renovate the whole paddock. And I guess the point that Pat was trying to make, and I fully support it, is that make those roadways, don't keep recultivating your traffic lanes, because as soon as you recultivate them, you're just going to go and put a bit of machinery over and have to repack them. Look after the soil in your plant zone. So you differentiate your paddock into your traffic lane, your plant zone, and you can bring that into those rice systems as well with GPS guidance now.
Yep.
Ripping isn't going to help in that sodic country. Again, like those sodic layers are tens of centimetres deep, and they go down to 80 centimetres a metre. Where Pat was indicating that it's useful is if you've got a pan and you break that pan, you then get roots through it, and that then increases your rooting depth. And by destroying that pan and getting roots through it, you've probably solved that problem as long as you don't recompact it. In the sodic country, you'll rip it and you'll get either irrigation or winter rainfall, and it will just slump and melt back down again, and you're left with what you had. The solution is gypsum, but if you want to keep your water use for rice down, then you don't want to put a lot of gypsum on, because you'll open that country up and then you'll increase your rice water use. Now, where we were out at Talakul, Mike Chalmers, whose place it was telling me afterwards he's thinking about putting in beds. And beds on that country work because you improve winter drainage, you get a protected plant root cropping zone and a traffic zone, and it's differentiated. And you actually, by taking that topsoil out of your furrow and putting it into your bed, you get an increased depth of topsoil in your bed. So all of those three things will work to make that system at Talakul, for instance, more effective, and you will get as good a yield in an average and good year and a better yield in a wet year, because you won't suffer from waterlogging. So overall, in the longer term, you improve your bottom line. Yep. Long-winded answer, James, but
no, that makes sense. Like, I guess, like, just getting back to what this project's aimed at, we're just trying to get field tests. So like what Sam was talking about there, just a simple dispersion test. It's something that you can easily do in the paddock. You don't have to wait for soil lab results to come back. It's probably easier just to see the visual results in the paddock, and you do the test, and then that's gonna show you what sort of effect your tillage is going to have.
The dispersion test, it's actually real, because Acidity, it is driven by chemistry, but it's actually the physical reaction of the soil to water that has the big difference. And so you can get two soils with an ESP of, say, 8, and one won't disperse and the other will. And that may be due to organic matter, it may be due to clay mineralogy. It may have to do with the electrical conductivity, but it's actually the behaviour of the soil that dictates, and it's the dispersion that's the issue, not the ESP. That makes sense. So by doing that really simple test, and anyone can do it, you actually get an indication of how your soil is going to behave with that water. And if you pick rainwater, well, it's indicative of a rain-fed system. If you pick channel water to do that dispersion test in, it'll show you how your soil behaves in reaction to channel water. If you're irrigating with groundwater, well, then you could do that dispersion test with your groundwater. I would do both, fresh and ground, but you can see the difference.
No, that's a good point, Sam. I guess if you got your soil test back and you saw a high ESP, so high sodium, which is what Acidity is, then you're thinking you might get a sodic effect in the paddock. But if you've also got salinity or a high EC, then that's going to cancel that out. So you're not actually going to see the physical, what you just said. Just because the lab result says one thing, when you go out and do this dispersion test, that's the real world, what it actually means. So you may not actually get that sodic impact. So I guess that's a good test. Yeah.
I mean, where the chemical tests come in, James, with ESP is you get an ESP, you'll get a cation exchange capacity, the depth of your horizons, and then you can put those numbers into a gypsum calculator, and you can play around with that, and it'll give you an idea of how many tons of gypsum in order to get a desired change in ESP to a desired depth. And so it becomes then a tool you can use with that chemistry to do your finances on, basically. How much gypsum do you want to put on? What's it worth to you?
No, that's awesome. Is that calculator, is that on DPI website somewhere? Or?
No, it isn't. It's a bit of software called Gypsy.
Yep.
And if you Google Gypsy, James Cook University,
yep.
Greg Ham, I think, was the writer of that bit of software. And it's still up there on the James Cook University website, last I looked, which was not that long ago.
Yep, no, that is awesome. Just got a question here from Carl, who who's at Griffith, and he's an ag teacher there. So he's running an ag plot and basically got hard setting red soils and just want to get better aeration. So I guess it's sort of similar to what Pat was talking about. You get hard setting red soils. How are we going to aerate that?
The textbook system is that the Tatura soil management system. So where you you loosen the soil, you add sufficient lime and gypsum to stabilise it, you grow some ryegrass, you wet the soil slowly, meaning you use trickle irrigation rather than flood, and you end up with more stable soil. That'll do.
That's
right.
That's the theory.
That's the Rolls-Royce job.
It is the Rolls-Royce job.
Sorry.
It's quite difficult.
That'll do.
Yeah, Harold Adam and Judy Tisdall, I mean, Bruce Cockcroft, they did all that work at Tatura well, it's not that long ago, but long enough. But even when you do that, I know Bruce noted that they still had some soils that slake down. It depends on, Carl, it depends on what you're trying to grow, and you need to have a look at your rotations and crops. If you do have those soils, in the long term, the better option for it, if you're not relying on cropping income, would be to turn it into pasture.
I think that just about covers it. Righto. Thanks, Pat. Thanks, Sam, and everyone for taking the time today. And if you've got any questions, just get in contact with one of the guys, and I'm sure they've got plenty more information. So thanks a lot. That's it. And talk to you all later.
Thanks, James. Thanks, Pat.
Yeah.
Good day, everyone.